Alright guys, hello. Where did we leave off last time? We were about to move on to decimal numbers. We talked about integer variables like byte, short, int, and long, discussed the relationships between them, and understood the logic. Now, all the other structures from here on actually continue in the same vein. So, there aren't many differences. We'll just learn over time how to choose between these, meaning when to use integers, when to use decimals, or if there are other numeric types we can use. Right now, we're just learning the basic parameters of programming. These are things that are the same in all programming languages. That's why it will be beneficial for us to learn the topics in this section step by step, in small pieces. Now, let's move on to decimal numbers. We'll be able to go through these parts a bit faster now. Our first decimal variable is a variable called float, friends. Just like an integer, this one also has 32 slots. But there are a few more details about these. I don't want to get bogged down in too much detail. I mean, things like floating point variables, this and that, the details, the certain standards there. There are lots of details, like how these can be used in different fields, different for numerical calculations, different for financial calculations, and so on. We won't get into those now, but we will over time. I mean, everything has its own order. But I don't want to give you all the information at the wrong time and make it meaningless. There's no point in making things harder than they need to be. So, we're talking about decimal numbers. Friends, there's really nothing to exaggerate here. With regular integers, as you know, you only had the whole part. Like 3, 5, 7, right? When it's a decimal, it's like 5.2, 7.25. For example, that's a decimal number. We have two types of variables that can represent this. One is float, and the other is double. Logically, when we compare them, float is similar to integer. And with long, we have the next decimal variable, which is double, guys. With long, its size and equivalence are also similar. Let's quickly check these out. How are we going to check? Let's write it like this. Decimal numbers. Float. The type of the variable is float. Let's say the number equals. But there's a problem with the variable here, teacher. It seems like it can't be assigned. I mean, it looks like there's an issue. You wrote it, but there's a problem. Yeah, it looks like there's a problem. Let's take a look. When there's a problem, it underlines it. If you're experiencing an issue like this, friends, if it underlines the expression you wrote, it means you have a syntax error. In other words, you've written the grammar incorrectly. So, who knows that I've written the grammar wrong, teacher? How can it see? How can it know this? The thing that helps here is your IDE, friends. You know, earlier I had you install something called IntelliJ IDEA in the first sessions. I'm talking about the window where we're writing code right now. Since this IntelliJ IDEA application knows the basics of the application you're writing, that is, it knows what syntax Java has, how it's written, and what its parameters are if you write the grammar incorrectly, it warns you like this and gives you a direct warning when you hover over it. It says, the required type was float, but the value you provided is double. Where have we seen something similar to this before? We saw it with long, friends. When assigning a value to long, long would say, hey, I want a long, but you're giving me an integer. Here, The situation is kind of the opposite. We're requesting a float, but it's telling us that we're giving a double. So, what was the deal here, friends? In these kinds of cases, it's about the default data type, friends. For decimal numbers, the default data type is double. That's why when you write a decimal number, the system automatically interprets it as a double. So, what are we supposed to do about this, teacher? Just like with long, where the default value you enter, the numeric value, was interpreted as an integer, here it's interpreted as a double. What did we do? We would add an L at the end so it would be recognized as a long. And this one is float. So, adding an F at the end will do the trick, guys. Alright, pay attention to this. It already warns you anyway. There's no chance you'll write it wrong. The other one is double. Guys, let's call this one a double number as well. As you can see, this way you can use expressions that are longer, meaning both the integer and decimal parts can be longer. Its precision is higher. Of course, you need to be careful when using it. In some, situations, it might cause you trouble, so you need to pay attention to this. Now, here, it's important to note that decimal numbers also include integers. Guys, decimal numbers are designed to encompass integers. That's why you can assign an integer to a float. Why? Because, when I talk about these little boxes, I'm referring to the logic behind it. When I use analogies to explain things, it tends to make the situation more understandable or memorable, right? An integer variable is something like this. It consists of whole numbers. Let's call this an integer. So, what about float? Let's think about float. For example, this is an integer. Now, float is like ... let's just call these boxes, boxes, dot, box, 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 box. Logically, when you look at it, integer, dot, decimal number. So, can an integer fit into a float? It can. So, when we think of their widths as 32, yes, since the integer doesn't have a decimal part, it's not a problem. I can assign this to that. So, can I assign a float to an integer? I can't. As you can see here, it has a decimal part. So, there's a part that doesn't match. If you really insist on doing it, then you'll need to test it. Let's illustrate this with an example. Now look, can integer be assigned to f number float number? Let's see. F single number equals 6. What did he do that you've seen without having to cast anything? I was able to appoint. Now let's print this to a screen. Let's say it is a float number. Now, what's normally inside the float? Friends, there is a whole number, right? So, when we look at it, we've got an integer value here, number. We've assigned this number to a float. So, when I print it to the screen, what output do you think I'll get? When I look, the value I get, the integer part, look, the integer part stays exactly the same. It says 0.0. Why? Because, guys, when you convert from an integer to a float, there's nothing transferred from the decimal part. But sir, why does it show the decimal? We assigned an integer. Look, the logic behind variables is this. Variables, by their design, are separated into integer and decimal parts, for example, for floats. So, when printing or using them, they are used together with both the integer and decimal parts. That's why it appears as integer 0.0. So, 55,443.0. So what happens if we try to do the exact opposite? For example, let's say we assign 25.8 to fsae here. Guys, alright, let's call this 1f as well. Then, let's assign fsae, the float number, to say 6. And here it says, hey, I can't assign this to that. Cast it to integer. So, if I use sout and print say 6 to the screen, what will come out? Come on, let's see. Look, what came out? Now, what was this normally? 25.8. So what came out here? The integer value came out. So, can we say that when we test it here, we drop the decimal part and get the integer value? We can say that, to some extent, because there are such long numbers that when you cast them, due to their structure, they round up. Friends, they round up. Or, well, that's what I wrote. Think of it like this. 9, 9, 9, 9, 9, 9. Let's say you wrote it like that. When rounding, it tests as 26. You need to pay attention to these things. And you also need to be careful when assigning these to each other, friends. That's how it is with our decimal numbers, friends. First, we'll finish our variables, then we'll do some simple exercises about them. That's all for our decimal numbers. See you in our next lesson.